welcome to the ODC. Mr. Tiwari, all set for your presentation?
Yes, ma'am. Thank you very much.
On behalf of the university and Vice Chancellor, Dr. Tabriz Ahmed, I would like to welcome all of you for this ODC for our School of Engineering and Sciences scholar, Mr. Anupam Tiwari. And thank you, Professor Gupta, for agreeing to be the examiner for our scholar. He gets 30 to 35 minutes for his presentation, following which he'll be examined by the ODC committee, starting with you as the examiner, and then the ODC committee members would be asking them questions. I'll request the non-ODC members to not ask any questions directly, but if anybody has any questions, they can type them out in the chat box, and we'll ask them on their behalf. So wish you all the best, Anupam, and all the please. You can begin now.
Thank you very much, ma'am. Good afternoon, everyone.
All the best, Anupam. All the best.
Thank you, ma'am.
Anupam, all the best.
Thank you, sir. Good afternoon, everyone. I am Anupam Tiwari, and for the next about 35 minutes, I'll be giving out my brief on the works that I have done under Dr. Usha Batra. The title of my thesis is Blockchain-Enabled Cyber-Physical Systems on Distributed Storage. The outline of the presentation is as seen on the screen: introduction, LR, gaps, questions, research objectives, research methodology, works, conclusion, future scope, publications, achievements, and concluded by the references. So the title is Blockchain Enabled Cyber Physical Systems. So there are three keywords there. One is the blockchain, the other is the cyber physical systems, and the third is the distributed storage. Now these three terms expand into a number of terms which at the onset of the thesis I have discussed in detail, while here I'll be just giving you a brief introduction of what these terms are and how are they connected to each other. So IoT, IIoT, Industry 4, cyber physical systems, blockchain, and distributed storage. So four overlapping technological terms. So why do I say that these IoT, IIoT, Industry 4, cyber physical systems are overlapping? Because during the course of my literature review, I have whatever number of papers that I have gone through, I have read through, all the authors have synonymously used IoT, IIoT, Industry 4 and cyber physical systems into each other. So while a author may be speaking about IIoT, but he may be referring as IoT. While he may be speaking about or writing about or working on IIoT, he may be referring to it as cyber physical systems. So the good thing is that all these terms, all these work that I have worked on for the last about 5 years, all these are evolving new generation technologies. IoT, I'll not expand on these. This is basically the network of devices that contain the softwares, firmwares, and they basically connect into each other. And IIoT basically gets into the industrial part. It gets into more peculiar part of the industrial part. Then Industry 4, again, factories and supply chains, interconnected, advanced networking, computing technologies. Cyber physical systems, again, the definitions, all these are basic definitions, comprise interacting digital, analog, physical, and the other components, engineered function through integrated physics and logic. Now again, when I speak of cyber physical systems, I'll take few minutes here. The authors that I mentioned, the literature works that the literature review works that I mentioned, all these had something in common, that CPS, some authors considered CPS and IoT with a partial overlap. Some authors considered CPS and IoT to be the same. Some authors said CPS is a subset of IoT, and then CPS has a subset of IoT. That is, IoT is a subset of CPS. So basically, so much of things are into each other. But NIST, the National Institute of Standards Technology, that basically as on date defines, it has again come up with a white paper on cyber physical systems, which basically defines, culminating all these into one thing, that is cyber physical systems. And we can refer cyber physical systems by the IoT, IIoT, Industry 4. Then blockchain, the simple definition says the distributed ledger of cryptographically signed transactions that are basically grouped into blocks. Then distributed storage. This is the most interesting part of my work, which I have come across. Refers to the infrastructure that can split data. Now, as I grow into the presentation, the peculiar problem that I'll come on to will be resolved with this distributed storage part only. So it refers to the infrastructure that can split data across multiple physical nodes, and it takes the form of a cluster. So this is the Gantt chart, which basically shows my progress over the last 5 years. So I'll skip this with not much time. Basically, I started my work in July 2017, and over about 8 semesters till December 21, till I submitted the thesis, my work was on. My literature review is still on. In fact, few developments have taken place just 2 hours back today, wherein I'll be discussing in the course of presentation. So motivation for the research: global realization of the derivatives and strength peculiarities of blockchain technology. I'll not take time to justify myself that blockchain technology is a buzzing word globally, not just in India. Global lookout beyond cryptocurrencies. While blockchain at the onset, when it originated with Bitcoin in 2009, 3rd January, the first block was mined. The focus in the first about 5-6 years till about 2014. 15, the focus was on cryptocurrencies only, and there were multiple variants of cryptocurrencies followed exactly on the lines of Bitcoin, but with a few different architectures. Now, after 2015, after this Ethereum was introduced, the world came to know the power of blockchain. Smart contracts would have been possible. Now, when smart contracts came, the world started seeing beyond cryptocurrencies. So this is what my work follows from here. Even governance across countries associating with blockchain. So if you might have come across multiple news that Dubai is one of the countries wherein it is taking on that blockchain will be taking on the governance part. And apart from all these medical, cyber physical systems, smart cities, smart buildings, grids, subsets of CPS, all are vying to associate with blockchain. And it is just not a global phenomena. Even in the recent works, in the recent document which has been introduced by the Government of India, National Strategy on Blockchain, it defines that India is on way. India has a vision to incorporate blockchain into many of the domains of governance. But surprisingly, while blockchain is all about decentralization, is all about distributed networks, but surprisingly, in all the works which are majorly moving around in form of anything, whether it is the CPS, whether it is smart buildings or smart cities, the storage is deemed central. So while blockchain is meant for negating the mediator, so blockchain, all the properties, transparency, immutability, etc., they are being derived for the benefit of implementation in various domains. But while we associate with all these domains, CPS or smart buildings or medical cyber physical systems, the data part again is being looked into for storage in clouds. And this is the case with most of the things which are being seen globally. While with cryptocurrencies, the transaction size is pretty mass. One transaction is about 385 bytes only. But while we associate with smart buildings, smart medical systems, and smart cities, Internet of Vehicles, smart grids, there the size comes into GBs, TBs, petabytes, exabytes, etc. It is here that distributed storage is associated. So with the literature review, it went on with, started with multiple reads on the papers and articles, and IEEE Explore, Science Direct, ACM, Springers, and multiple. I had my keywords, blockchain, distributed storage, and distributed IPFS, SWARM, SIA, etc. All these are distributed storage protocols. And then I shortlisted the papers for my final shortlisting and final reading and final basically filtering. So because there was dearth of data, dearth of work in blockchain domain. Now, blockchain has not originated from the academics. It has originated from, if I say, it has originated from grey literature. Grey literature in the sense, while Satoshi Nakamoto introduced this concept in 2008, 31st of October, he uploaded this paper. It was in a simple community. It was a local community of about 50-60 members. So it originated from there, and thereon it has evolved itself into a major domain globally. So I had to take into consideration also the grey literature part, apart from the established journals and articles. So literature reviews. So I have few slides here wherein I have considered the important papers to be mentioned here. So in all these papers, they have proposed various architectures. They have proposed various solutions that how blockchain can be good for Internet of Things, or how blockchain can be good for privacy of the user transactions, or how blockchain can dwell into multiple subsets of cyber physical systems. So the thing is, in all these associations, in all these proposed architectures, they have taken that storage will be central. Storage will be either in a cloud or in a local data center. So that kind, basically, this was the pickup point, which at my onset of journey, Dr. Usha, my supervisor, had given me she just dropped a hint that while so much of work is being done, what is happening about the storage part. So it was here that I realized that the storage is central. While we keep speaking good about the blockchain, we keep deriving so many characteristics of the blockchain, immutability, transparency, and so many other things. But the main part, while we associate all these domains, the main part, the storage, how can it remain central? It also has to be extended into this part. It should be distributed. So various works, in all these works, IoT, smart contracts, edge computing, smart vehicles, sidechains, etc. In all these works, the storage was either not spoken of, or maybe when it was spoken of, it was just spoken of at a very conceptual level without any proof of concepts. So in my journey, about 5 years, 2017, 18, 19, 20, the works which basically homed on about blockchain mechanics in 2017, there were multiple works happening around. And all these works I have mentioned in my literature review, blockchain platforms. There was so many blockchain platforms evolving, and whatever were there, much work was being done about them. Trust, CPS and IoT, blockchain matrix challenges, and over a period of say about 5 years, this has now, when we see anytime we see a new paper, it has to have association with CPS. It has to have, in majority of the papers, their distributed storage is mentioned, because the world has realized that this part cannot remain the central. Because in case we are trying to secure something, in case we are trying to derive the benefits of decentralization, storage can't be kept central. Storage can't be kept central. It has to be decentralized. It has to be distributed. So going ahead with this, so after this literature review, I had come up with made up a small chart with basically reflected the blockchain challenges. So there are a number of challenges. I'll not discuss each one of them because paucity of time, but I have mentioned it each and everything in detail in the thesis. So all these are the blockchain challenges. And when we go further, if we see in particular throughput, latency, and speed of Bitcoin mining, computational race games, or duplicate key generation of ECC, a very interesting part, lack of control. So all these are immense challenges which are happening around. And my screen can be further full, but I have limited myself to the major challenges, which blockchain challenges that I have identified with the literature review. But among all these three highlighted things, throughput, storage, and metrics, are the key focus areas of my research work. Blockchain consensus, again, consensus is the most important part of the blockchain, and it basically is responsible for negating the third party. So whenever we are speaking about implementing blockchain, the purpose is that we negate the middle party, we negate the third man, we negate any kind of contractor which is doing the thing. So here consensus plays a very important role. So for the thing that I was mentioning about 2 hours back, now Ethereum blockchain, on which some of my work has been there. Now Ethereum blockchain, from today onwards at 12:15 IST Indian Standard Time, the proof of work the consensus proof of work has shifted to proof of stake. Now this is a very big thing which has happened to the Ethereum blockchain, but I'll not discuss much of it. But the thing is, what I wish to tell you about here is this blockchain Ethereum, the blockchain complete the technology around is evolving at a very fast pace. So I have identified research gaps. So applications were limited to coordinating machine-to-machine communication, CPS subsets, resolving digital identities, and so on, proposing framework, etc. So all these applications, basically the major work which was done in this blockchain-enabled cyber physical systems has been limited to these domains. Research gaps. Now, as I have already derived my purpose that storage, the part of storage is central. It cannot be kept central. All multiple models, all whatever have been associated, they have assumed that storage will be central. Now, because storage cannot be put in blocks.
Ankit, I'll just remind you, I'm sorry I'm interrupting, I'll just remind you that we'll have to adhere to the time, please.
Yes, ma'am, 2:45. Okay. So research questions: how can blockchain enable an efficient CPS ecosystem of network? How will blockchain handle cyber physical systems with large storage? Can smart contracts enable efficient cyber physical systems? What will be the key metrics? These were the research questions. Now these questions I will not just try to justify why are these important. So they have a global interest, and in fact our country is taking keen interest. They have already released this document, Indian Blockchain Strategy, in December 21. And the research objectives include identify peculiar applications of blockchain in cyber physical systems, establish proof of concept for blockchain enabled cyber physical systems on distributed storage, determine smart contracts implementation, and try to find out where all it can be used apart from the stock exchange and the trade which is currently being used for the maximum usage, and derive performance metrics of Bitcoin. Research methodology. This goes on. Again, in case we have time, I'll be able to discuss this at the end. But this basically comes out that the research work has been exploratory and followed a snowball non-probabilistic method, sampling method. Since this has been more of a exploratory work. So based on the research literature done and gaps identified in concurrence with research objective, my problem statement, again I'm repeating, is blockchain enabled cyber physical systems on distributed storage. And before I share my works, what I have done and what I have achieved, this slide basically represents one single slide wherein I have tried to mention all the hardwares, operating systems and applications and tools that I have used for coming out with the work results. So the work details, these are the 5 domains: healthcare, smart cities, smart buildings, Bitcoin fork metrics, and smart grids. So first of all, I will be just discussing what these works refer to, what I have done, and then followed by the summary of findings in all of them, common to all. So medical CPS enabled on permission blockchain. So on the screen, what you see there on the lower side, patient 1, patient 2, patient 3, I have simulated multiple number of patients on multiple number of operating systems and devices. They are generating data. And this data is being, I have used the multi-chain blockchain here. Now multi-chain is a Bitcoin blockchain fork, and this data is being stored on this blockchain. Medheal that I have created with the IP addresses. This basically refers to all the patient ID, patient nodes, what operating systems they are using, what was the IP configured, and what were the addresses given. Now all these addresses given are the blockchain addresses of Medheal blockchain which I have created for the work. And these are the default ports, configuration parameters for setting up blockchain. Again, most of them have been configured peculiar to the requirements of blockchain. For example, this is one text medical advice. Now medical cyber physical systems encompass a number of responsibilities to derive from blockchain. So suppose this message I have given, text medical advice, one should maintain a minimum distance, this complete sentence I have converted into a hexadecimal equivalent. Now I have published the same on the blockchain, on the Medheal blockchain. Now when I publish the same, this complete highlighted thing 4F6 onwards, this is the basic text which is stored on a blockchain. Now when I say blockchain published, that means all the nodes that I have simulated, the same thing is populated at each and every node, and every node I can check the hash. Also, apart from the message, I was able to transfer confidential data. So I have got two nodes here. One has the data, and one is the other node which is expecting to receive this data. So with going through a number of steps, 1, 2, 3, 4, 5, 6, as enumerated, as seen on the screen. So I got the data, I encrypted the data, I published it to a blockchain with the help of streams. That is a feature built into the multi-chain blockchain. And after this was published into the blockchain with the help of the public key private key set, the user, the other end, the node 2 was able to derive the complete patient data. Now, as you see on the lower right corner here, eco patient extractor here. So this is basically a sample data that I published to the blockchain, and I got it on the other node. The other work is blockchain enabled reparations in smart buildings. Now smart contracts, as I said, mostly are being used for the trade activities, identifying what will be the kind of deriving benefits from for economic purpose. But smart contracts have got huge scope in blockchain enabled cyber physical systems. Now how I have just taken one simulated, I've used the cup carbon simulator, which is again an open source simulator. So I have taken few buildings from the university campus, and I have placed some sensors there. I have placed the sensors, and I have simulated that one sensor gets faulty. In scenario, I have taken scenarios 1, 2, 3. Among these three scenarios, traditional, automated, I'll discuss here the smart contract enabled. So with this figure, we'll be able to realize that this is the building, a defect is reported, the defect is detected, a HEPA filter, that is there's something got to do with the air conditioning, this is detected as failure. Now when this is detected, the smart contract gets activated, and a service request generation is activated and going through a number of channels. But the purpose is there is no third party involved here. In a typical buildings, if we speak about smart building, we have to have inevitable thing like building management system. This complete thing is removed, can be removed if we follow or if we try to implement and try to exploit the smart contract. So these are few screenshots that I have taken by deploying the smart contracts on my blockchain. Again, few screenshots of how these smart contracts were deployed, what were the addresses, what was the gas used. Next, I come to the distributed storage enabled blockchain for smart cities. Now, this again has got, I have simulated 6 nodes referring to governance, highways, health, monitoring, data centers. This schematic basically shows that here, this is the smart building. All the data sets, these all are providing in some manner or the other, they are providing data sets to the smart building. These data sets are being input and published to the blockchain on IPFS, and with the help of smart contracts activation, we have been able to realize a number of smart contracts. Whether if an accident happens, how does the ambulance reach there? If a doctor is there around, how does he know immediately without getting through the police vehicle or any kind of mediation in between? The middle part is removed. The smart contracts can take on. So these are basically few screenshots, again deploying of these smart contracts and how these smart contracts can be derived for the betterment of the complete overall ecosystem, overall system. Now again, this is one part related to distributed storage. Now how, like what am I explaining is that it is not so easy. Like I have been explaining that we can store in distributed storage, we can make use of distributed storage, but again there are challenges to it. Now challenges in the form that as we increase the data size, so in this table we see the data size in MB, so 10 MB, 100 MB, 1000 MB, and we go down to about 73 GB kind of data. Then on the horizontal sides, here you see the RAMs that I have taken. So there is a collinear, there is a linear relationship existing. So the thing that I wish to bring out here is the moment, or as we build into the storage, there will be some hard requirement of infrastructure. It requires some infrastructure at the user point, at the user node. So blockchain metrics is another. Now again, with respect to the works which are happening in blockchain metrics, I have done my own classification. They are basically can be classified into two things: empirical and stochastic modeling. So I have not taken into consideration the stochastic modeling, which is basically works on deriving the quantified probabilistic method, but I have focused on the monitoring, the simulation part. So cardinal metrics in Bitcoin blockchain. What are the cardinal metrics in Bitcoin blockchain? Now, for sake of this work, I have focused on the Bitcoin blockchain, on which a number of forks are presently available. And in particular, I have used the Bitcoin simulator, wherein I have been able to play that how small tweaks in RAM, in CPU, in hard disk, in block size, how all these tweaks can affect into the blockchain performance. So again, TPS, blockchain propagation time, nodes power. So this is one data which has come out, that in case I keep my block size MB, now this is the default Bitcoin blockchain, the column number 1, default design parameter 1 MB, block generation time 600 seconds. So 600 seconds is 10 minutes. So this is the default things. But in case I try to increase the block size, so why should I keep it to 1 MB? I can increase it to 400 MB, and I can get more transactions per second. But it is not so easy, because mathematically we'll be able to get all these, but when we do it in the real terms, because when P2P comes, a whole lot of other parameters also come, that leads to bloating of blockchain, and basically it slows down the blockchain. So transactions per second gets further reduced. In a typical Bitcoin blockchain, the transactions per second are 7 transactions per second. Ethereum is about 15 to 18 transactions per second, while in case we try and compare all these transactions per second speeds with Visa, MasterCard, what kind of transactions they are handling is about 15,000 transaction to 20,000 transaction per second. So that's a phenomenal difference between while we try and achieve all this, the blockchain implementation. So this again, I have derived multiple data readings for 10 minutes of block generation time, 20 minutes. I have reduced the block size, I have increased the block size, I have kept the block transaction time second. So here in this graph, the propagation time, it increases, while on the right hand side you see the 1 MB, 5 MB thing. So these are basically the block sizes. So as we increase the block sizes, the propagation time increases. When propagation time increases, it affects into the performance of blockchain. Similarly, the miner's mean block propagation time, this also gets affected in case we try and simply increase the block size. So IPF is enabled. This is again enabled smart grids on the blockchain. So this schematic brings out the flow process of how I have derived. So data set is generated at the SEG, smart electric grid. Then with the help of a small web application, I have been able to upload this data to IPFS. This data gets uploaded to the IPFS. From IPFS, I get one single hash. This single hash I'll be able to publish into the blockchain. And so here, this is the web application screenshot that we see. We browse it here, we upload the data set here, we derive this QMCX, this is the hash, and this we publish it to the blockchain. So while we publish it to the blockchain, so we are actually only storing the hash, and the storage part, the bulk part, about whatever is the size, that is being stored at the IPFS, the interplanetary file system. That's a different. So these are few screenshots which have come up. So these screenshots basically come up, reflect the use of wallets, how the wallet is being used to connect and transfer and deploy the smart contracts. So summary of findings. Now all these few works that I have mentioned here, now I'll just derive the findings. So one of the papers, that coalition of IoT and blockchain rewards and challenges, that basically was a literature review. Blockchain secured smart buildings as cyber physical systems. The findings are basically, I was able to establish 8 transactions count, deployment for 4 smart contracts. I was able to mine 8 blocks. Now this was just the beginning of my works. So that was in 2017-18. With a simulated gas, I was able to define gas prices, gas transaction things, transaction genesis blocks, and the further Merkle trees, Patricia trees within the blocks. How are they connected? I was able to derive them, quantifying, was able to see it, not just conceptually, but with the actual creating a blockchain and seeing all this transaction taking place. Then medical cyber physical systems, again a lot I have already discussed in the slides, but here I have used all the existing technologies. Now blockchain, again I'll just mention it, it's not a new technology. Even in 2009, blockchain Of course, it is an amalgamation of multiple technologies which have been existing with us for last about multiple decades, from 60s, 70s, 80s, whatever number of cryptography works have been there on proof of work, they all have been amalgamated together. So in this medical cyber physical systems, I have used amalgamated all the existing technologies, basically open source, AES for encryption, etc., to derive how can I publish it to blockchain and how can I exploit to the blockchain. Cardinal metrics in blockchain, as I discussed in the slides, propagation time, TPS, transactions per second, node, CPU, RAM, I was able to tweak them, see the results, give out the results, and then smart contracts enabled reparations. So in a typical smart building scenario, so here these are just the quantified things that I am showing on the screen. Otherwise, in these slides I have discussed what was the architecture, what was the flow. So reparation smart contracts were deployed, the middleman was removed. There was no requirement in this particular case for a building management system for a person to reach the room, check the sensor problem, and give the order to the vendor. So again, IPFS enabled blockchain for smart cities, IPFS enabled smart electric grids on blockchain. They move around the common thing in different architectures, that I have a data, I upload it to the IPFS, I upload it to the distributed storage, and I publish the hashes on the blockchains rather than keeping it very heavy. So coming to the objectives. These objectives I have taken from the earlier slide. Identify applications of blockchain in cyber physical systems, and what are the findings. So identify applications: smart cities, smart buildings, healthcare, grids, medical cyber physical systems. Establish proof of concept, established with published work. All these smart contracts, etc., they have been published in good journals. And so basically the objectives, this one slide basically defines my objectives, and whatever number of papers I have published, how are they connecting you to each other, fulfilling the requirements of the works. Work sequence, research gaps. I identified research questions, I derived research objectives, I was able to task myself. Then all these tasks and the findings I have already discussed. So conclusion: propose simulated models in different works for multiple subsets of CPS clearly derive a desirable relationship between CPS. So the association is definitely, it is inevitable, it has to happen, it will happen. To get the true realization of decentralization, CPS would need respective architectures extended with distributed storage. So whenever we speak about anything associating blockchain with HR records or Aadhaar or anything, we have to think where will the storage take place. If we are looking for central, so there is no basically purpose that we are achieving with the help of implementing blockchain. It has to be extended, that storage part has to be extended. And distributed storage protocols, currently all the distributed storage protocols, IPFS, SIA, Swarm, Storage, all these do not have any kind of encryption methods inbuilt to them. I have to apply another layer of encryption using OpenSSL methods to encrypt the data and then derive it decrypting. So future scope: inbuilt encryption to distributed storage, yes. Side chains for interactive. Now side chains are, suppose we are working on a blockchain, another country is working on a blockchain, why a country, why another state is working on. As on date, currently about 27 states are already working on different blockchain projects, land registries, RTO, vehicle selling, etc. Now all these are different blockchains. Side chain means how can they speak to each other, how will they be able to communicate with each other. Sooner or later, we are only moving towards a cardinal point. We have to be ubiquitous. The thing has to be communicable. We cannot create isolated islands of information and then derive and be happy about it. Everything has to be communicatable, interoperable. So measuring decentralization is another one thing, wherein blockchain creation, not a problem. We can take open source code, we can make own blockchains, but we have to measure it. We have to ultimately derive the benefits of it. Global blockchains will be there. Handling V's of big data, again this again becomes part of the distributed storage. In fact, Hadoop file system, the big data, the most famous, has recently, about last year, come up that their storage part will be associated with distributed storage. So you see, even big data companies, MongoDB, all these Hadoop, etc., they are associating and trying to associate with and try to exploit the distributed storage. So this is all. It is at the point significance. Okay. Limitations and challenges. Scalability is one thing because I have been able to do every work of mine in a very limited scale. Lack of blockchain platforms. What I have been moving around is Ethereum and Bitcoin Fox. So there is basically certainly a lack of platforms wherein we can play more. Side chains awaiting development. Data capturing capacities of devices. Now, whenever we see that we'll capture the data from smart buildings, it is not so easy that we'll be able to capture those devices, all those sensors. They have to be embedded with something that they are able to give data. The sensors they are not meant for storing data. The sensors are meant for quantifying something, measuring something, and then feeding it somewhere, or we are able to read it. But then in case we try and associate with the existing blockchain, Ethereum or Bitcoin Fox, anything, these devices, they have to be compatible enough. Interoperability, smart contract languages. Currently, whatever I have worked is Solidity, but again, this ecosystem is expanding. Solidity, I did not mention in the challenges that the versions in my 5 years, there have been about 32 updates. 32 version updates, and in most of these updates, the problem is that in case I write a smart contract today, that will not be compatible with the smart contract version which comes up tomorrow. So this basically shows my scholarly publications, what are my paper titles, and the number of citations can actually give a reflection of how much of interest the world is taking in this domain, blockchain and cyber physical systems and distributed storage. In one of the papers in the IPFS enabled blockchain for smart cities, these are just 18 citations in 1.5 years. So for me as a research scholar, in year and a half, if I am able to see 18 citations, it only makes me happy that the work is being cited and the work is being checked out and tried, been actually read about. So these are my few scholastic achievements, and in next few minutes I'll just complete all these few mentions in the books. All these certificates basically reflect all my workshops that I have participated in, that I have taken at some times. I was also listed in top 100 cybersecurity professionals in the country, and a few regular webinars, few mentions in the newspapers, few that workshop that I had taken in premium institutes of the country, and Gurgaon Police. All these are basically my journey summary in the 5 years, and these are the references. So herewith, as directed in 35 minutes, I've taken about few minutes extra, 39 minutes. So I conclude with my presentation here, and I am open for questions, please.
Yeah, Anupam?
Yes, ma'am.
Can you hear me?
Yes, ma'am. Yes, ma'am.
Yeah, you have done very good job under guidance of your supervisor, Dr. Usha Batra.
Absolutely, ma'am. Dr.
Your
Usha
presentation flow was very good. And your citation of work reflect your direct, influence of your paper, that how much it is useful for your society. So your citation of the work is also what I see in your slides. That very good. So it is really a good job done.
Thank you very much,
so
ma'am.
You just tell me like.
Thank you.
I don't see any questions in the chat box also, so I'm assuming there are no questions from the participants also. Therefore, it's time for me to ask the ceremonial question now from the examiner. So, Professor Gupta, do we now have your permission to award the provisional degree to our scholar, Mr. Anupam Tiwari?
Yeah, surely. Yeah, he has done a very good job, so surely. So, congratulate Dr. Anupam. Congratulate to your supervisor also. So
thank you, ma'am. Thank you very much.
Congratulations, Dr. Anupam.
Yeah, Dr. Anupam Tiwari. Many congrats.
Thank you, ma'am.
Congratulations to his supervisor also.
Yeah. Congratulations, Dr. Anupam Tiwari. Wish you all the best.
Thank you very much, ma'am. Thank you very much, ma'am.
Yes, congratulations, Dr. Anupam, Dr. Usha Batra, and to the School of Engineering and Science.
Ma'am, before we end, I've already spoken much, but one single point of whatever achievement I have done, I only attribute it to Dr. Usha Batra, who has been one single point of reason of my journey, of my moving ahead and moving not just ahead, moving with so much of exposure. in case I am speaking today of cyber physical systems, I still remember I was hesitant in taking, but I ventured into this CPS, and each and every learning that I have gained because of COVID. Of course, I may not have been able to personally take it from her, but she has ensured with her blessings always at any point, every point of time. Heartiest thanks, namaskar, and charan spursh, ma'am. I'll definitely do this charan spursh, not just digitally, but I'll make it soon.
We
Person
used
to
to
person.
say that sky is the limit for the scholars like you, but beyond the sky, we have satellites now, so you'll go beyond the sky. All the very best for and the journey has just begun.
Thank you,
So
thank you
always
very much.
remember, it is the journey of research and it has just started. So all
Thank
the
you.
very best, and you're one of my very proud scholars. God bless you.
Thank you very much, ma'am.
Congratulations once again, Dr. Tiwari, and thank you so much, Professor Gupta, for joining us online. Sir, would you like to say something to our examiner, external examiner, Professor Rashmi Gupta?
So thank you, Mr. Gupta, for finding time and also able to ask very good questions. Thank you very much.
Thank you everybody for joining. Thank you so much, Professor Gupta, and congratulations once again to Dr. Anupam Tiwari and Dr. Usha. And I'll request all the ODC members to please submit the evaluation sheets that you would have received along with this invitation email to the COE, so that the provisional degree can be issued to him at the earliest. Thank you so much for joining.
Thank you.
Okay, good, sir.
I'm fine. Thank you. Many congrats to you.
Thank you so much, sir. Thank you so much.
Bye.
Thank you, sir. Thank you, ma'am. Thank you very much, ma'am.